Tonight's special guest speaker, Holly Abeels, is the Florida Sea Grant Extension Agent for the University of Florida IFAS Extension Office in Brevard County. Holly holds a bachelor's degree from Long Island University and a master's degree from Florida Gulf Coast University. As a Sea Grant Extension Agent, Holly's job is to bring science-based information to the community, covering topics related to natural resources, sustainability, climate change, water quality, conservation, and much, much, much more. Tonight, Holly will be sharing with us a fascinating story all about horseshoe crab biology and conservation. Folks, please help me welcome to the stage Holly Abeels.
Thank you so much, Zach, and to Florida Oceanographic Society for inviting me here today. I'm really excited to be talking with all of you about horseshoe crabs, and I even brought some props here, so if you've never seen one in person, you're welcome to come up when I'm done speaking to look at them and touch them if you want, and to talk about a statewide citizen science program right here in Florida that's looking at horseshoe crab populations across the state. So I'll get right into it. So this is me again, so thank you, Zach, for that great introduction. And I do work for the University of Florida Extension Office in Brevard County, which is 3 counties north of here. How many people are familiar with University of Florida Extension? Oh, a couple, great, okay, awesome. So you guys also have a great extension office right here in Martin County. And so I highly recommend, if you've never had a chance to visit your extension office or to learn about the different things that they do, please do take a minute to go to their website or go to their location. I think Vincent told me that they're really close, maybe 10 minutes from here, so I highly recommend using their resources. They are resources for the public, so we are here to serve you and to provide great educational opportunities, sort of like this one, where I'm coming and talking to you guys about this wonderful program. So I have sort of 4 areas that I'll be covering today, talking about horseshoe crabs. I'll be talking about what a horseshoe crab is, in case you're not familiar with them and what they are. And then I'll be talking about their population and the management of horseshoe crabs. And then the citizen science program, the Florida Horseshoe Crab Watch, and how you can become a volunteer if you are so interested in doing that. So, what are horseshoe crabs? They're pretty strange creatures, as you can see in this picture, and I have a couple up here. So it's something very unique, something that probably don't really see very often since they do live in the water. And they kind of look like little tanks, right? They have a really hard shell. They're walking around, and their name is a little misleading because they are not actually crabs. They are arthropods. So arthron meaning joint and pos meaning foot. So they have a jointed foot, and they're actually not crabs. So they're actually more closely related to spiders and arachnids. Don't let that scare you, okay? Spiders are cool, okay? Spiders are cool. So they do have this kind of armored body shell. They have these jointed appendages. And so even though they are grouped into the crustaceans, I just want you to remember that even though we call them horseshoe crabs, they're not actually true crabs. So like I said, they are more closely related to arachnids or spiders, so they're way past ancestors are actually extinct scorpions and trilobites. But they haven't really shared a common ancestor with other organisms for over 400 million years. So they are very ancient species. They've been on this earth for a long time. And because they've been on the earth for over 400 million years, they've actually survived a lot of mass extinctions. So you can think of things like dinosaurs that are no longer around, right? Horseshoe crabs survived those types of things. And they're often called living fossils. And one of the reasons why they're called that is because their body shape hasn't really changed in all that time. So you can see all the way on your left, the oldest known fossil of a horseshoe crab. That's from the Paleozoic time frame, which was 445 million years ago. Looks very similar to what our horseshoe crabs of today look like. They look even more similar if you look at the Jurassic about 215 million years ago. So that body shape has pretty much stayed all the way up into the present. And then our species of horseshoe crab, which is called Limulus polyphemus, has this ancestor all the way on the right from the Jurassic 150 million years ago. So it's that saying, like, if it ain't broke, don't fix it. This body shape has survived, has allowed them to survive for a really long time. So why change it if everything is going well? So because they are very old, they've kept that same body shape for a really long time, and none of these living fossils, they also have what are called primitive traits. Primitive meaning they're very similar to their ancestors. So like I said, they pretty much have kept that same body shape. They've kept sort of the same characteristics, called primitive characteristics or primitive traits. And that's why they get the name of the living fossil. So these different traits that you can see, they have 5 pairs of legs. So that's common to their ancestors that they have today. Their mouth is actually in between their legs. So it's at the base of their legs, they have these kind of chewing, scratchy mouth parts. And that's what they're actually using to kind of grind up their food and eat. They have what's called an operculum and book gills. So the book gills are what they use to breathe, and they are called that because they sort of look like the pages of a book. So when they're flapping, it looks like pages flapping back and forth. So that's why they're called those book gills. So those 3 traits right there are things that they've had for these millions of years for such a long period of time. So they do breathe by taking in water through that operculum and those book gills, and they're crawling around on the bottom using their feet and their kind of mouth parts to find food and to eat a variety of different things, which I'll talk about in a minute. So they do have this really hard armored shell, but it's not devoid of sensory receptors. So they actually have a lot of different types of ways to sense their environment. They have their regular lateral eyes, so the 2 eyes that are at the very front, kind of at the top of their body. So those are their compound eyes. So they can see movement, they can see objects. It allows them to see what's around them, what's happening. They also have, at the very tip, a median eye. It's a UV light sensing eye, and that sort of allows them to see different wavelengths of UV light. It allows them to kind of figure out daylight, nighttime, sort of what's happening around them, what's other types of things that they can see. They also have what they call light sensing eyes on their tail, and this helps them to just figure out whether it's dark or light. They also have light sensing parts underneath, so that way when they flip themselves over, that sort of helps to let them know not only that they're upside down, but they can actually see, because of that light, that they're upside down, and they can use their tail to flip themselves over. So they have all these different types of senses, so that way they can figure out what's going on around them. They can kind of sense when there might be predators or prey, and because they live in our estuaries and in our really shallow waters offshore, it could be really dark, it could be really muddy, all these different things could kind of inhibit them being able to see. So they have all these different types of senses in order to determine what's happening around them. Don't you wish you had that sometimes, so you could see behind your head? Yeah, definitely. And then they also have tactile and chemical senses. So they can kind of feel, obviously, when things are touching them or when they're rubbing up against stuff. And their chemical senses also help them to smell different things. Males actually use them to help find females when they're out in the water. So if you don't remember anything that I've talked about tonight, I want you to remember this one thing. Horseshoe crabs are not dangerous. So people think because they're kind of armored, they have this tail, they think, tail, stingray, it's going to sting me, right? No, they're perfectly harmless. And when you do see horseshoe crabs on the beach, which I'll talk about why it is that they're on the beach in a little bit, sometimes they get flipped up upside down, and they're not able to flip themselves over. So they do try to use their tail to flip themselves over, but sometimes their tail gets shortened. Sometimes it's they just can't really right themselves. So normally they would try to dip their tail into the ground and flip themselves over. So I recommend to you, if you do see a horseshoe crab upside down, is to just flip them over. So as you can see in this video, the person just holding them on the side of their carapace like this, and very gently just flipping them over so they can walk away. She actually is bringing him or her a little bit closer to the water so they doesn't have quite as far to walk. So don't be afraid of them. They're not dangerous. They're not going to hurt you. They're really gentle creatures, and really all they want to do is flip themselves back over and get back into the water. So not dangerous. Remember that. There'll be a test later, so this will be a question on the test. Hi, so like I just said, sometimes the horseshoe crabs, you see them in the water, but also on our beaches. So what are they doing when you see them on the beach? This is how they actually reproduce. So unlike a lot of animals, a lot of invertebrates, they actually come up on shore, on our beaches, to lay their eggs. And what they do is they pair off when they're offshore, a male and a female. The male has these, what they call claspers, so they're kind of like little boxing gloves. And they actually use that to hold on to the back of the female horseshoe crab. And then she has to carry him and her up on the beach. And and I do have a male here, so you can kind of see when you come up after the little kind of claspers that they have. So once they find each other offshore, they'll come up on the beach, and the females will lay their eggs, and the males will fertilize them, and then they'll go back offshore. So they pair up. Actually, this time of year, this is a great time of year to actually see horseshoe crabs come up on our beaches. So the program I'll be talking about later, actually our surveying starts usually January, February, March, and April. Sometimes we go into May. So this is a great time of year if you find a sandy beach to check out to see if maybe horseshoe crabs are up on the beach and laying their eggs. So they pair off offshore for about 1 to 3 weeks. And they will come up continuously up on the beach to lay their eggs. So the females lay, usually kind of dig down into the sand. As you can see in this video, on the further left, there was kind of a female sort of like digging down, like right into the sediment. I have a couple other pictures I'll show you as well. And she's trying to dig a little hole. So she's trying to dig about a 10 to 20 centimeter hole, and she'll lay about 2,000 eggs in that hole, and then the female or the male will fertilize them. If she's not disturbed, she could potentially, during just that time that she's on the beach, dig several holes and lay all her eggs that she'll lay for a season. So she'll lay about 60,000 eggs during the season. And if she is disturbed, she might go back out, go back in the water, and then come back at another time to continue to lay eggs. So, but she does it in those batches of 2,000 for a total of about 60,000 eggs a year. And so once she's done laying their eggs, she's done for the season. But males will come back repeatedly. So they'll release from a female, go find another female, attach to that female, and they can kind of continue the cycle of fertilizing eggs throughout the entire season. So they're sort of constantly coming out during the months that this event happens and fertilizing eggs. And one of the really interesting things about horseshoe crabs is that fertilizing actually happens externally. So it happens in the sand, which is very strange. So they're kind of using the water movement of the water lapping up on the shore and like the moisture of the sand itself to help the eggs and the sperm to find each other and that fertilization to happen. So it actually happens outside the body in the sand during that time. And that's unlike any marine arthropod that you could possibly think of. So there's no other invertebrate that does this. So like I mentioned, males attach to females. The females bring herself and the male up on the shore, and they lay their eggs. And that is what we call a pair. So we have one female, one male. That's a pair that come on shore to mate and reproduce. So you can see here in this picture, you actually have 5 sets of males and females that are up on the beach. So we have, looks like 3 pairs that are on the left side of the picture, and then 2 that are on the right. So you count 2, 4, 6, 8, 10 individuals, right, all together. So this is very common. That's one way that eggs get fertilized, one way that mating happens. But this isn't the only way that this occurs. Sometimes males can't find a female. So they're kind of like, well, I need to do something else, right? I want to be able to reproduce and have my own young, right? So in this picture, you can see I've circled 3 pairs. So a male and a female, and they're doing their thing. They're laying their eggs. The males are fertilizing. But on this other side, there's clearly more than just, say, 6 individuals, right? So we have, on the top left, we have 2, but there's actually a female that's underneath that. So that's 2 males that are on top of a female. In the next lower left, we have a female that's dug herself under. You can actually barely see her. And there's 3 males on top. And then on the lower middle part of the picture, there is a very dug-in female. She actually kind of made a mound, so there's sort of like a mound of sand on top of her. And again, she has 3 males. So you're probably like, well, those guys are really intruding on, what's going on here. So what's happening? And I've laid out those other males that are actually not attached to females, but they've come up and they're also trying to fertilize eggs. And actually, that's a really smart strategy. So they actually have a chance of being able to fertilize eggs and to have their sperm mix and to reproduce and have offspring. They actually have, I think, let's see if I have it written down here. Give me 1 second. Yeah, I think they have like a third of a chance of like basically being able to reproduce and have their sperm fertilize those eggs. So this is the other strategy that males can use if they're not attached to a female to lay eggs. And we call them satellite males. So they're hanging out on the side and they're finding a pair that's mating, and they're gonna come in to the side and release their sperm when the females release their eggs. So everyone wins in this situation. Everyone gets to have a chance. They're not necessarily gonna be like pushing the male that's attached off, but they're still able to get in there and do what they need to do in order to do what we do, right? So this is what we do. We continue having young. And so you might get a situation like this where you're like, wow, there's a lot of things happening in this picture, right? So, and this is actually a very common site where I live. We have, in one of the sites where I have volunteers go and survey for horseshoe crabs, this is a very common sight to see. Basically, a bunch of horseshoe crabs all crawling out of the water, all releasing eggs and sperm, all these different things happening, going back in the water, coming out of the water, going back in, males, crawling around. So this is actually a really common sight to see a lot of different things sort of happening. And if you become a volunteer for the Citizen Science program I'm going to talk about, you actually learn to decipher this picture and what's going on. So if that sounds exciting, if you like puzzles, this is something really fun to learn about and just trying to figure out what's happening and how to interpret this nesting behavior. And I highly recommend, if you ever have a chance to come up to my area, near Merritt Island National Wildlife Refuge, you should be so excited to hear from Charlie next week. He's amazing. But one of the sites is right near Merritt Island National Wildlife Refuge, and this is very common to see. Okay, so they've laid their eggs. You can see up there on the top left that nest. And so the eggs and the embryos develop in the sand for about 1 to 2 weeks. And then they turn into embryos for 2 to 4 weeks, depending on the temperature, and they kind of hang out in the sand to sort of develop. And then the embryos emerge, and they are then called trilobite larvae. So trilobite because that's their ancestors were called that. So that looks just like that little middle picture. It's basically a little baby horseshoe crab without a tail. So they're not feeding during this time. They're sort of hanging out in the sand, maybe free swimming a little bit for a couple weeks. And then they molt and metamorphose into a really tiny little baby horseshoe crab. Isn't that the cutest thing you've ever seen? And so that's the little baby horseshoe crab. So now it's a juvenile. It's going to look like that for the rest of its life, except it's going to keep getting bigger and bigger and bigger. This is why I love invertebrates. I know people are like, sea turtles, amazing. I mean, little baby horseshoe crab, that's just. So let me see if I can, might not be able to, but so they metamorphose, and then they're hanging out sort of in shallow water for a long period of time, and then they continue to molt and get bigger. So just like crabs and lobsters, they have to shed their skin in order to get bigger. And then in this bottom video right here is actually a double time lapse of a horseshoe crab shedding its skin. It actually takes several hours for this to happen. So it's taking off its molt, its outer shell. So I have a little molt right here. So the outer shell of the horseshoe crab looks just like the horseshoe crab. It sheds it, and then out comes a bigger version of the horseshoe crab. It sort of fills itself up with water to make itself bigger. So they do about 16 to 17 molts over 9 to 10 years. And that's sort of like their juvenile stage. And then once they get to that final molting stage where they're not going to molt anymore, that's when they can actually start reproducing. So it actually takes 9 to 10 years from when they're really, really small in order to get to reproductive age and to become part of the population of being able to mate and continue with the life cycle. So molts often get confused for a dead horseshoe crab. So they look very similar. I encourage you to come up after. You can feel this one. It's really light. This one, very heavy, because it still has all its body parts and everything like that. Another way you can tell a molt is you can see from this video that's sort of pushing out the front, right? So all molts have a slit at the very front of the shell, and that's how you can tell a molt from just a dead horseshoe crab. They always have that slit because that's how they're crawling out. So I brought props, so you guys can touch and feel and look at later. He's like almost done. So they are, like I said, arthropods, so they are related to spiders, most closely related to spiders, but also crabs and lobsters. So if you've ever had like a soft-shelled crab, you're basically getting a crab that's recently molted. That's basically what that means when you get a soft-shelled crab. And so it's gonna kind of kick off the molts, and then it'll be done. Again, this takes usually like a couple hours, so this is sort of a sped up version of this video. But you can see how much bigger it is compared to its molt, right? It's like expanded in size. It has that, kind of takes in that water to help to make itself bigger. So they have that final molt, and that's when they can start breeding. So they won't grow any larger. That's as big as they're ever going to get. They're never going to get any bigger. That's also when the males get their claspers. And so you actually can't tell a male from a female just by looking at it when they're young, because they all look the same. The males don't have those claspers, those claws, until that final molt. And they'll live about 6 to 8 years after molting. So they're a pretty long-lived species, right, for an invertebrate. Pretty long-lived, 15 to 20 years. And because they don't ever molt again, sort of that condition of their exoskeleton, of their body itself, deteriorates over time. And so they'll get things like barnacles. They'll also get like pock marks from running into things or from things trying to eat them or run into them. And we actually use sort of that level of deterioration of the shell to age the horseshoe crabs when we're doing our surveys as well. So that's something else that we learn. And that just helps to show basically how healthy the population is, because we want young, old, and somewhere in between. We need all of those, right? Because we know the young are, maybe 10 or 11 years old, so they're right in the beginning of their reproductive age. When you get to like 15, 20, kind of near the end of that, right? So we need all different age levels in order for the population to continue over long periods of time. All right, so now that you all love horseshoe crabs and you've learned all about them, I'm going to talk a little bit about horseshoe crab populations and management. So there are 4 species of horseshoe crabs in the world. We have 1 species over here in North America, and then there's 3 species in Asia. And our species is found all along the eastern coast of the United States, around Florida. It sort of skips a couple states, and then in the Yucatan Peninsula of Mexico. So that's a pretty wide distribution if you think about it, right? If they're all the way from Maine, all the way along the Gulf and then to Mexico, that's pretty wide area, wide distribution of population of where they are. And so we know that they are found all around in those areas. We also know that they don't necessarily mix from one area to another. So there's like a Gulf of Maine population, doesn't really mix with the Mid-Atlantic population. They sort of stay together. Then we have a southeast population, that's South Carolina and Georgia. We have a Florida East Coast and Florida Gulf Coast, which has 2 or 3 different populations. And then we have the Yucatan. So we don't really know what separates them. It could be salinity, it could be water temperature, it could just be barriers that's in the, in the water, things that kind of get in the way from them moving from one to another. I was talking to a lady up here about Long Island, so maybe the island gets in the way, so they can't go further south. So there's all different types of things. But they are distinct, so which is great in that we can kind of learn more about what that individual population is doing in that certain area, but bad if one population is declining more than another. So we know that there's evidence that the New England, so that Gulf of Maine and the New York population has had a lot of decline. So if they're not necessarily mixing with the population south of that, obviously that population is in more likelihood of maybe being threatened or going extinct. The Delaware Bay and the southeast populations are fairly stable, so their numbers are pretty stable. Delaware Bay has probably some of the highest numbers of horseshoe crabs in the United States. It's a very popular, or well-known, I should say, population of horseshoe crabs. And then in Florida, it's sort of unknown. We really just started understanding what the population looks like in Florida, and we only really have maybe like 10 years of data, not even. So we're not really sure what the population is doing quite right now here in Florida. But the Citizen Science Program is helping us to find that out. So I should also mention, which I think I mentioned in another slide, but I just want to mention it here. All of these populations are managed by the Atlantic States Marine Fishery Commission. And so they actually regulate all of the populations of the horseshoe crabs that are found in the United States. It doesn't matter where they are located. So even here in Florida, we sort of report our population numbers to the Atlantic States Marine Fisheries Commission. So here we are in Florida. So we have these sort of separate populations, obviously very local. Florida's a really large state, right? So we have a lot of area for horseshoe crabs to cover. Here in our Indian River Lagoon, that's where we see our horseshoe crabs. They're not necessarily always going to be leaving the Indian River Lagoon to go offshore. They're mainly staying in the lagoon as far as we know. So, but if you go to the Gulf Coast, they're in the Gulf. They're like on that continental shelf, hanging out. There are some populations in the local estuaries there. But again, there's just kind of those boundaries that sort of separate one to another. And we really need more data about what all the Florida populations are doing. We're really especially unsure about the south part of Florida population. So they're really important ecologically, so they're really important for the food web in our estuaries. They eat mainly worms and clams, but there's a lot of things that eat them or eat their eggs. I actually had to add alligators on there because there have been some pictures documenting alligators eating horseshoe crabs. But when they're little, they're pretty vulnerable. They could be eaten by fish or other bigger crabs, maybe sea turtles. Shorebirds love the eggs, so when horseshoe crabs are laying their eggs, afterwards you often see a lot of shorebirds on the shore picking at the eggs, so that's really great. A lot of energy, right, for those shorebirds. So really, really important, just like a lot of organisms that live in our environment or live in our estuaries, they're really important in that food web of being able to feed other things and to feed on stuff as well. And then one bird species that makes them even more important is a threatened species of bird called the red knot. So this bird actually winters at the very southern tip of South America and migrates north to its breeding grounds in Canada, in the Arctic. And so one of their stopovers is actually in Delaware Bay, and they time that stopover for when horseshoe crabs are laying their eggs in that area. So that way they can basically eat as much as they can and fuel up before they continue into Canada. So that's one reason why we need to know how the populations are doing, because they're really important for a lot of different species, like the red knot, which has this huge migration that it does and needs that population of horseshoe crab eggs in order to continue its own life cycle. So like most animals, I think, in our environment, they have a lot of threats. For our horseshoe crab, threats include development, so they do need sandy shoreline in order to come up on the shore to lay their eggs. And so without a sandy shoreline, they're not able to do that, so they're not able to reproduce. Here in Florida, we do have an aquarium trade for the horseshoe crab, where the young are taken out of the water and then they're sold to aquarists. So that's a big part of them being taken out of the system, and that just hurts that if they're taken out as juveniles, they don't have the chance, right, to reproduce, so they're not getting to that age where they can continue that. Shoreline erosion, sea level rise, and then in some areas where they're located, beach driving can be a problem. I know near where I am, one of the beaches that we survey is a really popular beach for people to park, and they hang out in the water, and they go out on their jet skis or paddle boards, and so they could have potentially vehicles or other things like that, run into them when they're there. So these are some of the major threats to horseshoe crabs, which is why they are heavily managed in order to see what their populations look like. They also are really important in the bait industry, so they're collected for bait for the whelk fishery, or the eel fishery, and so they actually use them for bait for that. And if you read Zach's little intro for this talk, he talked about how their blue blood is used in the biomedical industry, so that's another use for them. And so they're collected in several areas for their blood, which is used in the biomedical industry. And I do have a couple slides about that, so we can learn more about that. So like I said, here in Florida, the aquarium trade can be a potential impact, so we're taking them out of the system before they have that time to mature. Obviously, when they're really little, they're adorable, and they can go easily in different size aquariums and continue to grow for many, many years and survive. So this could potentially have an impact and stress the population over time. And sometimes people get tired of their animals, right, and they release them. And so if you're releasing animals into a system where they weren't there originally, you could be hurting basically the genetic population that's there right now and disturbing it if you're introducing animals that weren't previously collected from there. So horseshoe crabs are collected for their blood. Basically, every single person in this room has benefited from horseshoe crab blood because they collect this blood in order to take out these amoebocytes from the blood, and they turn it into this substance that's called limulus or lysate, LAL, limulus amoebocyte lysate, or LAL. And they use that in order to test any injectables for bacteria. And I don't have time to have you watch this whole video, but it's a cute little TEDx video, or TED-Ed video that talks about horseshoe crabs. Let's see how adorable they are. And them molting, and then they're going back into the water, and then taking them out of the industry. Maybe when we end, I'll put the video on, and you guys can watch more of it. All right, so like I said, everyone in this room has benefited from horseshoe crab blood. If you've ever had any type of injection, vaccine, implantable device, it's anything that's used in that you're actually putting some type of substance into a human. They have to test that substance beforehand in order to make sure it doesn't have bacteria that can make you sick. So this has been the standard test for all injectables since 1987. And there's 5 companies in the United States that collect horseshoe crabs and collect their blood. They do actually return them back to the water. So when they take them out of the water and take their blood, they don't take all of their blood. They do put the horseshoe crabs back in the water, even though there is I think a third of those that are taken out don't survive the process, obviously, but they are put back into the water. So in Massachusetts, New Jersey, Maryland, Virginia, and South Carolina, there are companies that are collecting horseshoe crabs and taking their blood in order to make this test. There's been a lot of news over the past several years about this because they're trying to create a synthetic version of this to use in place of taking horseshoe crabs out of the water. And so that's still sort of in the system of getting it approved in order to move away from taking horseshoe crabs out of the water and moving to the synthetic test, but it hasn't been approved quite yet. So horseshoe crabs are really important. There's a lot of different things that we use them for. They're really important ecologically. Obviously, in the biomedical industry, that's a $1 billion industry, so it's really important to know and have information about horseshoe crabs and what their population looks like. And we need this here in Florida because we have to report what our population is doing and what it looks like. Even though we don't have an industry for bait or biomedical, we do have the aquarium trade, and because horseshoe crabs are so important, we need to be able to know what's happening to our population, what the numbers look like. So because of that, the Florida Horseshoe Crab Watch Citizen Science Program was created. So this program is assisting scientists and researchers and managers, providing them reliable data so that way they can report that data about the population of horseshoe crabs. Remember I told you that horseshoe crabs come up on shore and lay their eggs? That's a perfect time for people to go out and count horseshoe crabs, right? So you can easily go to a beach when that's happening and count how many horseshoe crabs you see, and if you do that every time they come up on the beach, you can kind of see what the population looks like within a season and year over year. So in 2015, FWC approached a researcher in the UF biology department who was studying horseshoe crabs and tried to figure out how they can basically turn what researchers were doing, collecting the survey data, into a citizen science program. And this isn't new. It actually happens in other states as well. So they were able to look to see what other states were doing, take their protocols, their survey information, how they collected information about horseshoe crabs, bring that here to Florida and sort of test it out to see if it was something that regular people like you could go out and do. And there's certainly more of you than there are of me, right? So the more the merrier can help and collect this data. And that means we can do it all across the state and all the different areas that we see horseshoe crabs. So in 2016, my colleague, Savannah Berry, with Florida Sea Grant, joined the FWC and the researcher from the UF Biology Department, and she helped to create what the training and what the protocols would look like to actually train citizen scientists and have them go out and do this program. So that's when the program officially started. It started in Cedar Key on the Gulf Coast and then has expanded across the state. I learned about it in probably 2018 when my colleague was trying to do like a statewide training for coordinators to learn about the training and actually do the training themselves in the areas where they live. So I got to go to Cedar Key when horseshoe crabs were coming up on beaches and learn how to do the training so I could bring it to my area and to train volunteers and do it. So the program in the Indian River Lagoon, at least from Brevard down to Martin County, started in 2019. Volusia County had already been doing the program before that. They were on one of the testing sites. And those are two of my volunteers. See how happy they look? And this is a huge collaboration. Like I said, FWC, University of Florida, Florida Sea Grant, Nature Coast Biological Station, all of these people had a hand in creating this because it does take a village, it takes a team in order to create something and to bring it across the state. So this is a huge endeavor, and we collect data and we send our data to U.S. Fish and Wildlife Service, the Atlantic States Marine Fisheries Commission. So they're now understanding what our Florida population of horseshoe crabs look like. And so this is based on a volunteer program like Project Limulus. There are three things that volunteers do when you're part of this program. First is survey. So you're actually walking a known length of beach and counting how many horseshoe crabs you see. You're also documenting the number of males, the number of females, whether or not they're pairs. Remember I said female, male, pair. Satellites, if there's satellite males hanging out there. Also unattached males or unattached females. So an unattached male is one that's just on the beach looking to get in on the action, you know. And we also do tagging as part of this. So we take a subset of the animals that we're surveying and counting, and we apply tags to them. And these tags are given to us from the U.S. Fish and Wildlife Service. So there's a huge tagging program all across the United States. And so anywhere you go where there are horseshoe crabs, there could be tags on those crabs. And so we tag horseshoe crabs and we collect biological data. So we measure how big the horseshoe crab is, we weigh it, we look to see if it's damaged, so if it has like a clipped tail or missing legs. And so we have all that information so we know basically what that individual looks like and sort of like how big it is, how healthy it is. And we can kind of track to see what the population looks like over time for size, weight, male versus female, different things like that. And all that's stored in a central database that FWC holds, and then they're the ones who collect all the data for the year and send a report. So here in blue are all of the different counties across the state that are current locations for this program. So if you see your county on here, that means you can be part of this program. And then we're trying to expand in those green counties. So since 2015 and through last year, we're just starting the season now, so I don't have any numbers for this year, but we've had over 1,300 volunteers across the state. They've done over 3,600 surveys. We've counted over 221,000 crabs and tagged almost 13,000 of those. We've recited or seen tagged crabs, almost a little over 860 of them. So should have mentioned that, but tagging crabs also helps us to count or basically use equations to figure out what the size of the population is. So even though we've counted 220,000 crabs, if we know we've tagged almost 13,000 and we've seen like 860, that information can be put into an equation and we can actually extrapolate that to say how large the population is. So it's really more than the 222,000 we've seen because we know we've seen individuals again. And another really important thing that volunteers do, because if you've ever been out somewhere and you see someone holding a clipboard, you're probably wondering what that person's doing, right? Anyone? You see someone with a clipboard? You wonder what they're doing, maybe? Yeah, I know, I wonder. I'm not the type of person to ask what that person's doing, but there are people out there who want to know what you're doing if you're holding a clipboard. So you learn all about horseshoe crabs, all the things I talked about tonight, and more. And so when people ask you what you're doing, you can also educate them and tell them why you're doing what you're doing and why horseshoe crabs are so amazing and important. And actually, you could do that now, because now you've learned all about horseshoe crabs. So carry a clipboard with you that says horseshoe crabs on it, or carry a horseshoe crab, and then you can tell people about them. So like I said, horseshoe crab volunteers survey a designated length of the beach. They count the crabs. They look for tagged horseshoe crabs. It's really important to record with diligence, meaning that you're always double checking your numbers. You're always in teams, so you're never by yourself, so you can always count on each other to remember numbers, or for accounting, like I have a team here of 3 people, so we have one person with a clipboard, and then we have 2 other people who are actually helping to count. So you don't have to count and write down. I know I can't. I know we say we can multitask. I really can't. So I can't count and write something down at the same time, but if I have someone else counting, I can totally write down what they're saying, right? And then interacting with the public, which is really, really important because it just helps to get that message out about why horseshoe crabs are important. And then the tagging, which is the most fun part of the whole program. All volunteers love to tag because we all love to touch horseshoe crabs. And so we have these tags that we attach to the horseshoe crabs. And we see about maybe a little under 10% of tagged horseshoe crabs, which just means that those other tagged crabs are somewhere, right? There's a possibility we might see them. We may even see them farther away, you know, from where we first saw them originally. There was one survey or one report showing that there were horseshoe crabs, that one that was tagged in Cedar Key and then went up into like the Big Bend, the elbow of Florida, and was found up there, like in the Apalachicola area. So that's a really long distance for a little animal to travel. So we can know that too. We can know where it is that they're going when they're out in, because we aren't going to see them after they go out in the wild blue yonder. So we have to wait to see if someone sees them again. And then this is the type of information we can collect. So we'll know if they come back to the same site. We know how many males versus females there are, what the size of the population is, if it's a smaller population or a smaller size population. We can see over time what the spawning or the nesting trends are, so how many we see come up on the shore. And if those numbers drastically decrease, you know, we could say that there might be a problem with the local population, excuse me. And you know, what other types of environmental conditions might be influencing what the population is doing. So I want to throw just like 2 graphs out there, just so you guys could see what data looks like. So this is from 2022, and this is showing the weight of horseshoe crabs from across the state. So on the bottom are the different counties that participate in the program, and on the left is the weight in grams. So the blue bottom line, or the blue bars, is the weight of males. So males are smaller than females. We have to carry things around, so we have to be bigger. And then the red line are females, so they weigh bigger, they're bigger in size. So we can kind of see what that population looks like, what the weight looks like for different counties. I didn't have this highlighted, but you can see like sort of towards the right part of the graph, there's like a really high bar, red bar. It's like really at the top of the graph. Those crabs are from basically the Nassau County, or the most northern county in Florida. And the reason why that one is so much bigger is because Georgia crabs are huge. So they're actually much bigger than our Florida crabs. So sometimes we get some influence of Georgia into Florida. So that's why those crabs are much bigger. And then this is the size. So again, the counties on the bottom, all across, going from left to right, and then the width in millimeters. So we have males, smaller, and then females that are larger. Again, with that kind of outlier, sort of closer to the right with that red bar, much bigger crabs because the Georgia crabs are huge. And then in 2022, I just wanted to highlight that one year because it was a pretty good year. We had 608 unique sampling events across 38 sites, so that was 608 surveys. We counted 32,869 crabs and tagged 2,000, a little over 2,000 of them. Brevard County, we are really lucky because we have a lot of crabs, and so we see high numbers of them at especially at one of our beaches where we survey. So in the spring when we survey February, March, and April, so in 2022 we saw 23,700 plus crabs in our county. And then some counties survey in the spring and in the fall, and so Pasco County had the next largest number of crabs in their fall season for 990. If you want to see horseshoe crabs, come to Brevard, call me. I'll show you where to find them. Okay, so what can you do, or how can you become a volunteer? You can search for FWC Florida Horseshoe Crab Watch. This is the main page for the program. Oh, wait for it. I'm going to have a scan so you can just go right to the website in a minute. And so at the very bottom of this page, it lists all the counties that participate. And if you click on your county, it'll list the name and the email of the coordinator for your county, who you can call. Your coordinator, his name is Kirk Fusco, and he's with the Indian River Lagoon Aquatic Preserve. And so he would love to have you call him and become a volunteer. So, or you could scan this QR code, and that will bring you right to the website where you can look to see about becoming a volunteer. And so I just want to end with a couple slides to just say that citizen science is powerful. This data could not be collected without volunteers. There is no way that we could have gotten these numbers, seen where horseshoe crabs are being sighted or when they're coming on shore without volunteers. And volunteers are used for a lot of different things. Like Zach earlier was saying that they would love to have volunteers for different programs. You know, there's only so many researchers and scientists and nonprofit organizations or management organizations. We only have so many people. So we need people like you who are really interested in getting out there and volunteering for programs and to help collect this data and do this work. It's really, really important. And it really just helps to show that everyday people can be scientists and can go out and collect data. It's really easy. This is a great program. My volunteers are amazing, and they come back year after year. They're not afraid of me. They come back, so it's amazing. And we can prove that the data that you volunteers collect is just as good as scientists who spent tens of thousands of dollars to go to school, right? So on the right of each of these graphs is data collected by volunteers, and on the left of each graph, so there's 4 graphs, on the left is data collected by professionals, and it's basically the same. So that means that you are a scientist and a researcher, and you didn't have to spend all that money to go to school to do it. So. And we've had a lot of great feedback and support and press about this program. We even have artists who do beautiful art. I even have in my office a great photographer who took a beautiful picture of a horseshoe crab and gave to me. I have it hanging in my office. So this program has really expanded and just getting the word out, and I'm really excited that Zach had me come in so I could talk to all of you about this program and hope that you all get excited to become part of this program and to become citizen scientists. So if I haven't convinced you to do that, one thing you can do, besides remember, what was the one thing you were supposed to remember if you didn't remember anything else? Yes, great, you all passed. If you see a horseshoe crab, you can report it yourself. So FWC has an app, or you can just go to their website or call, go to their website and you can report your sightings of horseshoe crabs. So if you see a horseshoe crab, you can report it. That's how FWC collected the data before we started the citizen science program. That's how they knew what the population looked like, was just people calling or going to the website and saying that they saw horseshoe crabs. If you see a tagged horseshoe crab, even more important, you can call 1-888-Limulus and say where you found the horseshoe crab and the tag number. And I have some of these flyers in the back. So if you don't remember this, you could take a flyer and hang it in your neighborhood or wherever you see horseshoe crabs, so people know to report tagged horseshoe crab sightings. And like I said, this is a group effort. There's a lot of people who've been involved. I really want to thank not only my volunteers, who are amazing, the best volunteers in the whole world, but my colleague, Dr. Savannah Berry, who's helped start the Horseshoe Crab Watch program, and she really got me involved and excited about it. And so I've been doing this since 2019, and I couldn't have done it without her. And then all of the people who've been involved. We have lots of coordinators. We have lots of funding that's gone to start this program and to be involved. So it really is a huge group effort. And with that, I'll take any questions. Yes, question up front. Yeah, that's a great question about the tagging. So it is, you do puncture the shell and stick the tag in. I should have brought a tag to show you, but it's a really quick punch. It's sort of like, we liken it to like a bee sting, so it's just like quick, and then you stick the tag in. We need something that will stick in there like really well, so that way it won't possibly come out. So yeah, it is a puncture into the shell. Yes? Oh, so is there data on why they're only found in a small area of the world, like here in our population in the United States and then Asia? That's a great question. I am not sure of the reasons for that, but I might have to look into that now that you've asked that question. I don't know. Way in the back.
How long do horseshoe crabs survive outside of the water?
Yeah, so how long do horseshoe crabs survive out of the water? As long as their gills stay wet, they can stay out for quite a while. When we do our program and we actually have to take horseshoe crabs like off the beach or out of the water and do the tagging and stuff like that, we keep them in buckets in a cool place, and they're not out for very long, maybe at an hour at the most. But as long as their gills are kept wet, they're pretty good for a little while. So we try to make sure that ours aren't kept out of the water for very long, and we keep them in like a nice cool place and stuff like that, so they're so we know that they're safe and everything. Yes, go ahead, Zach.
All right, we have a ton of questions rolling in from our Zoom audience, and we'll try to hit some of these tonight. This is a question about reproduction. Do the young reproductive females produce the same number of eggs as the older ones, or do the number of eggs a female produce, does it change over the course of their life?
Yeah, that's a great question. As far as I know, it's that same about 60,000. So I haven't seen any data that says it changes over time, but as far as I know, it's just that same about 60,000 per season. I saw some hands way back there.
Do they come to shore to breed daytime or at night?
Yes, I didn't. Yeah, so when do horseshoe crabs actually come up on the beach? That's a great question. It's something I didn't go over. So they typically come up at the highest high tide during the new and full moon. And so that's when they actually come up on shore. So they want to come up when there's a very, very high tide, so the water's really high on the shore. So that way their eggs stay moist, but not inundated with water. I could have a whole lecture as to why our Indian River Lagoon horseshoe crabs are different. So they're a little bit different here in Indian River Lagoon because at least in my part of the lagoon, we don't have tides. So it's not like every day there's a low and a high tide. We're more of a wind-driven system. So our horseshoe crabs come up on the beach during high wind events. So right here in the front. Yeah, so do horseshoe crabs swim or scoot? So mainly they're scooting along the bottom. I think they probably could be like just slightly above if they need to get somewhere quickly, but usually they're just on the bottom, sort of scooting, walking around on the bottom. I think when they're probably in that sort of larvae stage, that trilobite larvae stage, that's the swimming stage for the horseshoe crab. Back there again? Oh, they're like, what do the horseshoe crab eggs look like? So they're really small, sort of like a greenish color. I'm not sure the size exactly, but they're, yeah, like a greenish, roundish color. Oh, Zach, go ahead.
So in some areas, we've seen an increased amount of sargassum washing up onto beaches, and one of our viewers on Zoom was wondering whether anybody has looked at the impacts of sargassum on horseshoe crab nesting because it has impacted sea turtle nesting and shorebird nesting in areas.
Yeah, that's a good question. I know we might not see as much sargassum like in our estuaries because it is mainly an offshore problem, but we do sometimes see sargassum on our beaches. I mean, in the areas where I've seen our horseshoe crabs, I mean, they can dig, they really do kind of move things around and dig well into the sediment. So, and some of our beaches are really shelly, so there's usually like a lot of shell and stuff, and they still are able to kind of get under there. But I'm not sure if there's been any research specifically to see if a high abundance of sargassum has affected horseshoe crabs nesting. Yeah, so the synthetic version of the LAL test versus horseshoe crab blood, that's, as far as I know, it is as good, and I believe there are some countries in Europe who have made the switch over, as far as I'm aware of, but it hasn't been approved yet. There's just more regulations, right, to get things like that approved. So I think they're just still working through like the system of getting it approved. Right here?
Same thing about the blue blood. Other sources of blue blood other than the horseshoe crab?
Yeah, so there are other sources of the blue blood. There are no other sources, so it's just from horseshoe crabs. Again, there's that synthetic version that they've created, and they're just trying to get through the system of sort of having that replace the horseshoe crab blood. Let's do Zach again, and then I'll come to you.
All right, we'll go back to Zoom. The decline in Chesapeake Bay horseshoe crab populations has been linked to the decline in red knot populations. Is the decline in horseshoe crabs in Chesapeake Bay solely due to harvest for the pharmaceutical industry, or are there other factors? And then second part of the same question, are there any other species that have a similarly strong link to horseshoe crabs as the red knot does?
Yeah, I'm not sure if it's only the biomedical industry, because there are other threats to horseshoe crabs. Like I said, like development, so like not having beaches for them to come on shore is probably another really big one. And I'm not as familiar with the Chesapeake Bay horseshoe crab, so I'd have to look to see what the research says about other reasons for the decline for the population. Yes, right here. Yeah, great question. So because the horseshoe crabs have their mouth like in between their legs, like what are they eating? So they're eating anything that's in the sediment, so mainly like worms and clams. And so they're kind of grabbing them with their feet and sort of the mouth parts and chewing on them. So anything really soft. If you ever go to like an aquarium and they have horseshoe crabs, sometimes they'll do demonstrations where they will feed them, and they'll usually like just flip them over and put a shrimp like where their mouth is, and you can see them like this. It's really cute. Yes, right here.
I was under the understanding that they come to the same beach every year to mate. Is that correct?
Yeah, do horseshoe crabs go to the same beach every year to mate? At least in the data or that I've seen for the horseshoe crabs in my area, we have seen individuals return because we do tag some. So we have seen individuals return to the same beach, but I've also seen an individual that was tagged at one site just south of Kennedy or Cape Canaveral Space Force Station, sort of like on the Cape Canaveral side of the Indian River Lagoon. Was actually seen at our northern site in Titusville. So they had to travel pretty far to get to that location, and they were seen up there. So coming up on the beach to, mate and stuff like that. So they can travel, but I have definitely seen some that have come to the same beach as well. I think there was one other, no. Zach, and then I'll go back to you.
All right, another Zoom question. Are there any areas that have been specifically set aside to protect and conserve horseshoe crabs?
So as far as I know, there haven't been any areas that have been set aside particularly to protect horseshoe crabs, but certainly areas that have been set aside for just conservation in general certainly help horseshoe crabs. So any like wildlife refuges or natural parks or other conservation lands, if they do have those sandy beaches, those certainly help horseshoe crabs, and we've seen a lot of those areas, like in Merritt Island National Wildlife Refuge. We do see a lot of high numbers of horseshoe crabs in that area because there's natural beaches and stuff like that. Go ahead.
Two parts. One is on the beach, why can't you pick them up by the tail? And two, if the horseshoe crab loses its leg or its tail, can it regrow back?
Great question. So first question was, why don't you grab the horseshoe crabs by the tail? Which is a great question and something I should have said, so thank you for bringing it up. If you grab a horseshoe crab, you always want to grab it by its sides. You don't want to grab it by its tail because there's a muscle that connects the tail to the back of the horseshoe crab. And if you grab them from there, you could damage that muscle, and then they would not be able to use their tail like to flip themselves over, so that it can harm them. So you always want to try to grab from the side. And then what was your second question? Sorry. Yeah, so if it loses its tail or its leg, can it grow back? I think when it's a juvenile, it probably could do that growing back, but once it stops molting, it's done, so it's not going to ever grow something like that back. Let me go, right here.
Do they mark the horseshoe crab's nest in areas where they do with turtles?
Yeah, so do they mark the nest areas where horseshoe crabs come up? There are some areas that have signs that say, like, this is a horseshoe crab nesting beach, but not all of the locations are marked. So it's mainly the areas where we do our surveying, and then if people report sightings of horseshoe crabs, we know that those locations are there, but we're not necessarily marking it specifically as a site. There are some signs that have been created for this program just to make people aware, and some of those are up, but not in all areas. Great question. Go ahead.
Why are some of the horseshoe crabs in your photos darker and others lighter, even though they are the same size?
Yeah, that's because of that aging. So really young horseshoe crabs that are at the age to be able to reproduce have usually shinier, smoother shells, and I've seen them be just a little that kind of lighter color, and then as they get older, they sort of get more darker shells. I think it's just over time, like things getting on the shell itself, that kind of just ages that shell. I think there was a question way back here. Yeah. Why do they allow horseshoe crabs to be harvested for aquariums? That's a great question that I don't know the answer to.
I can speak to that as a.
Oh, okay, go ahead.
They're good at keeping your aquarium clean. They can clean some of the stuff out of the sand and filter, not filter, but pick stuff out of the detritus. So they're part of a kind of a cleanup crew in home aquariums.
Yeah, probably like the same as like cleaner shrimp, or like you get the algae eaters. probably like similar type of, like, yeah, right, like a robot. You don't have to use your smartphone though to turn it on. Yeah, right here. What are horseshoe crab's biggest predator? Probably anything bigger than it. So I'm not really sure though. I guess it would depend on the size. So like younger crabs are probably a lot of things, like fish, regular crabs like blue crabs or stone crabs. As they get older, it would have to be something obviously much larger. So maybe like I know alligators is one, larger fish. When they get pretty big though, like there's not probably a lot of things that can eat something this big. Maybe sharks. Sharks might be one. But that's a good question. Yeah, anything that's bigger than it, it's definitely, but I'm not sure if there's one that's like the main predator.
Is the pharmaceutical industry taking all ages, or are they just taking the adults?
Yeah, for the pharmaceutical industry, what kind of individuals are they taking? So I actually just read something the other day about how previously they were only taking male horseshoe crabs, but I think they were trying to expand to also take female horseshoe crabs. But I think it would just be, I don't think it matters the age. I think they're just collecting, kind of ones that they see. I don't think there's a specific like age range, because you can't necessarily tell how old it is by looking at it. You could say like young versus older, but not necessarily like an 11-year-old versus like a 18-year-old type of thing. So go ahead, Zach.
Do they capture crabs for the pharmaceutical industry when they're on the beach trying to nest, or do they have to capture them from the water? And then is that process regulated at all?
Yeah, so they do collect them when they come up on the beach for nest, because it's an easy way to collect crabs. And there are regulations as to how much you can collect. I don't know the numbers for that, but yes, it is a highly regulated industry. Go ahead.
The purpose of the tail seemed to be stability to right itself. Can they survive without the tail?
Yeah, so can horseshoe crabs survive without their tail? Yeah, they do. They do use it for flipping themselves over. That's really the main use for it. And, maybe defense if it thought it could poke something, but it's not, it's really for that flipping over part. So if they didn't have a tail, they could survive. They just wouldn't be able to flip themselves over. And it's not just flipping themselves over when they're on a beach, it's also when they're under the water too. So they can flip themselves over like under the water if they run into something or something hits it or is trying to eat it and it somehow gets flipped over. So in that case, they also wouldn't be able to flip themselves over. So it's kind of that one way that they can do it, but they still can survive.
And folks, I think we have time for maybe 2 more questions here at the Blake.
Oh, I can't see you. Go ahead. Yes.
I'm curious about Palm Beach County. It seems as if there are populations there, but you don't have any statistical data. Is that because they're not being seen there, or you don't have volunteers to collect the data?
That's a great question. I'm not sure. I think Palm Beach County did have a coordinator, so it might just be not having enough volunteers. It could be the sites that they're going to, they're not catching them. But I'm not sure exactly as to why exactly they don't have as much data in that location. I'm not as familiar with that county. But they looked like they had a coordinator, so you could contact them and ask them. There is also on that FWC website, you can go back and look at the past year's reports. I think there's all the way to 2018 through 2020. I think 2022 is the last one. I don't think they've released 2023. So you could always look in the past and see what the numbers have looked like over the years at different locations.
Put that slide back up so we can take a photo of it.
Yeah. This one? Mm-hmm. Yes.
Are the populations of male and female approximately equal? It looked like there were more males than females.
Yeah, the populations of male versus females, are they equal? They are not, but I don't remember what the ratio is. I'll have to look it up. And I think this might be our last question.
Does the temperature determine the sex that comes out, like in sea turtles?
Yep, no, it's not like sea turtles where the temperature determines the sex. That's a reptile thing, so not an invertebrate thing. But great question.
All right, everybody, with that, let's give Holly a big round of applause and thank her for joining us tonight. And thank you to all of you, to our Zoom audience. I'm so sorry about our audio issue at the very beginning of the program. Thank you for letting us know. Please join us 1 week from tonight. Charlie Venuto is a phenomenal speaker. He's a great scientist. He's got a really neat story to tell, linking the Kennedy Space Center area, this modern rocket science-based community of researchers and astronauts and engineers, to a different community of folks who want to protect and conserve the environment. It's going to be a really nice presentation, and I hope to see all of you there. Thank you for coming out tonight, and we'll see you in a week. Bye, everybody.